Now let's jump in right away and build a simulation. So in week 1, we built the simulation in SOPs. So you drop a dot network here, which you can do, or you can do it out here in OBJ level, and it really doesn't matter. This is completely up to you. Maybe, I mean, in SOPs you can connect things directly here and then import like that, which some people, maybe you might find it easier. It really doesn't matter. We're going to do it out in OBJ though. Leave the name .net, so we'll change it to sim. And let's dive inside. We already have our output. So every .net is the same until you start to fill it. .net, you use the same thing for RBD or flip or pyro, particles, or vellum in fact. What's different are the solvers. So we're going to use a flip solver. Okay, so this is what actually does the work, and you can see there we've got a boundary. So this is where these are kind of like limits to where we can simulate. So we need to connect the solver up to the output, so everything will flow through into the output. So for any flip simulation, we need a flip solver, we need an output, and we need a flip object. And there we go, we can see something already. So right away, so the flip object is the actual geometry or particles, and these are fed into the solver. The solver calculates all the forces, velocities, viscosity, which we will be using, and moves the particles accordingly. So first thing I want to do is go to guides and to particles here, set to sprites. Let's change that to particles. That'd be easier on the computer. Okay, if we press play, nothing will happen. We don't have any forces. So let's add some gravity first of all. There we go. So that's pressing down, and then we should see them drop. What I'm going to do also, as we're working with particles here, let's change the background. If you press D on your keyboard, make sure the cursor is in this area. D, background, change that to dark, and I'm going to get rid of the ground plane as well, so we're not using a ground here. So we should see that just drop and disappear. So as soon as it passes out of the bounds, it basically the particles are deleted. We could just briefly, if I drop a ground plane, and merge that into our simulation. And if you remember to check this, what I tend to do is make sure that these are swapped around, and it's already intersecting, so maybe we will drop the position by 1. Oh, drop -1, sorry. There we go. And let's play that. There we go. We have our first very uninspiring flip simulation. But that is being simulated. It is working. But we have a lot to improve on.